So I will talk about the 4-bit magnitude comparator IC, which is 7485. I will just talk about the connection diagram here. So it's a 16-pin IC and I will just draw the block diagram. So just a connection diagram, and I won't draw the VCC or ground pin and those ones. So basically it's a 4-bit magnitude comparator. So let's say we want to compare two 4-bit binary numbers like A0, A1, A2, A3, like that, or let's write like this. So A3 is the most significant, and then A2, A1, A0. This is one number and this is the other one, and we want to compare these two. So basically it will have 4 inputs here for one number and another 4 inputs here for the other number. So if this is say B0 to B3 and this is A0 to A3. So two numbers, these are input pins, and then we have 3 pins which are also input pins that has this sign, so greater than, equals to, and less than. We have to look the pin numbers to find the actual pin in the diagram. So I'm just drawing the block diagrams here. So what happens is these two are grounded, the greater than and equals to greater than and less than ones, and this one is connected to a 5 volt, so plus 5 volt to VCC basically. And there are 3 output pins. One designates greater than, one designates equals to, another designates less than. So when I say greater than, it means A is greater than B. This is A is equal to B, and this is A is less than B. So this is our A and this is B. So two 4-bit numbers are fed here, and depending on the result, either one of these 3 outputs will be high. If they are equal, the middle one will be high, and accordingly. Now this is the block diagram for using a 4-bit magnitude comparator. Now if we want to use 2 bits that are higher than 4 bit, let's say 8 bit, two 8-bit numbers we want to compare which one is bigger or higher. So what we do is we just get another one of these this IC, which is another 7485, and it will have again two input pins here. Now since this is 8-bit, we will have A4, A5, A6, A7, and here we will have B4, B5, B6, B7. So two 8-bit numbers now. So what we will do is, here we have the lower significant bits, and here we will connect the higher 4 ones. So A4 to A7 here, and B4 to B7 here. And here we have again 3 input pins, which is greater than, equals to, and less than. And what we do now is we get the final output here, of course, because this is the final output, that whether A is greater than B, in this case the two 8-bit numbers. So this one, instead of this will not be floating, and how we will cascade these two, this is the lower one and this is the higher 4-bit ones. So this one will go to this greater than, this one will go to the equals to, and this one will go to the input less than. So these outputs is going to the input, these 3 inputs basically, for the next stage basically. So now we have already cascaded, and what will happen is, in this system, first this will check and this output will be fed here. This IC will check the lower 4 bits, and whatever the result is will be carried over in this one, and then we will get the final result here in these 3 output pins. And it's obvious that we can compare even higher bit numbers like 12 bits, 16 bits, and if we needed to compare, let's say, 6-bit numbers, what we would do is we would leave these 2 bits, we wouldn't use these 2 bits, these 2 pins. So we will just use, say, then we would have up to A5. So this would be A5 and that's it. We wouldn't have any A6 or A7 or B6 or B7, but that would be fine. We could just use them. And whether they will be floating or not, it will be dim, because we will have to look at the pin diagram, and if they are active low or active high, depending on, we will leave them open. We will actually have to leave them open in this case. We don't have to connect anything to that, so it will be just floating. So once again, the IC number is 7485 and we can just find the pin diagram in the data sheet.